Hello everyone. So let's try to learn AI engineering, and let me make it very simple for you. In AI engineering, your entire goal is to make API request to the LLM. That's it. Now you might think, Ajay, but I already know how to make API request, and I mean I'm a software engineer, right? So why do I need to become this AI engineer? Well, this API request that you are making to the LLM, it's very costly, like literally very costly. So your goal is to make sure that you want to use the LLM's capabilities but with very less cost. That's it. That's your end goal. And the way you are able to do is, once you understand this AI engineering concepts, that's how you are able to like utilize these LLMs capabilities at their fullest maximum post, the way you can use them and with very less cost. That's it. That's what you're trying to do it. Okay. So in this video, you're not going to become the best software engineer or best AI engineer out there, but it would give you a little bit idea of what's happening and maybe help you in your journey. All right. So let's try to learn it. So I'm going to start very like a simple way where it's like in a like intuitive way. Basically, so you want to utilize the LLMs tools. Now that's the first learn why do we want to utilize the LLMs. See, LLMs are very good at text based search. Like this context understanding, they are really good at it. So basically, if you like have this paragraph and you want to find the answer from this paragraph, so you can try this also on the chat gpt or anywhere. You just write a paragraph basically and then you ask some questions. Okay, answer me this question only from this paragraph itself, and the LLMs are very good at it. That's the capability that we want to use in our application also, that whatever the application that we are building. Okay, and that is why we want to use LLMs. Okay, so let's just say you are making an application. So let's just say this is a user, and user, I will just say user. Hopefully you are able to see it, but this is just a box that represents the application. Okay, now it makes some query. Let's just say ki I want to sign in into this application. I'm having a hard time signing into this application, something like that. User makes a query. It's a chat application, let's assume, and you have server which basically process this request, right? Whenever something makes a request, and there's this db, and there, let's just say, I will just say just goes through this. Let's keep it very simple. Okay, so this is server. So you currently nothing is like extraordinary in this. You already know this, and everything makes sense to you, right? So this is where this AI engineering part comes. Okay, on the server, this is where AI engineering part comes. Basically, this is where we will do everything that we want to do. Now, currently user makes a request that it says ki in the chat application, right, ki I am having hard time signing into this application. What do I do? There's something query, something like that. Now we get the query here and we will search into the LLMs. We get the query here and we will extract the query here, and then we will let just say ki LLM are here. It's not about the database, it's just I didn't have the space, so that's why I'm writing that down there. And we get this query. So query, I'm representing as a queue. We extract the query and we make the API call to the LLM. But do you see the problem here? Because it says ki I'm having hard time logging signing into this application. What do I do? And we pass this to the LLM ki okay, answer this. What do you think the LLM will answer? It will answer generally, like it doesn't even know what the hell this user is trying to log in which application we are talking about, what is the exact context. LLM doesn't know that. We need to provide that context, right? Because LLM works very good when we provide the right context. I hope you know that, right? So that is, as a like a AI engineer, this is our job, is to provide that. Okay, so this is where what we will do is we will store. So let's just say you have like thousands of docs or some document, docs, where you can look up okay, information, all the information regarding your application you have into the docs. Now we want to utilize those docs so that LLM can know okay, answer this query based on these docs. But you can't just attach these docs to every request, because that would literally just like shut down your application before even it even starts, right? Because it will be costly, right? So we want to make a smart decisions here, and this is where AI engineering comes. So what we will do is, before even it all even begins, what you will do is let's just say this is where your docs are, docs, And again, it's like a, I'm thinking out loud, so it's not like a structured plan, it's more like so you take this video as in like a, you know somebody is trying to give you the insight of that like entire process, but is it the exact way of doing it? No, it's not. So it's not like, particular course type way, it's more like I like it makes sense to me, that's kind of way. Okay, and based on this thing, now you pick up the topics and you go deeper into that on your own time, right? So you have docs, and now you want to store them into this like some place where we can attach the context. So we want to reduce the context, because attaching all the documents to the every request, and LLM will of course give the result, but we know that the document contains all kind of information, so there is no point to attaching all the documents. Instead, if the user is asking about signing in related like a query, so we will just attach that part. Where are the in the documents we are talking about the signing in related things, so we attach that thing. And maybe there are a page where we talk about how to sign in, what are the information that we should pass, like okay, use email password, capital, whatever the rules are basically. And this is where you on this page you click, and this is how you go to this login or sign up page, whatever that is. So we are talking about in only one page, and other pages are we talking about different things, so we'll only care about that one page. Okay, so what we do is, before you even start any of these things on the server, basically it's like we have the docs. What we do is we do the basic file reading, and from these docs we create the embeddings of it. And what does embeddings are? Basically it's like a numerical representation of the actual words. So see, currently in the like before we used to make a chatbot, what we used to do is, we have docs, we store these docs into the database, basically like parts key, okay, one page, two page, three page, we store them. But the problem is, if you try to like for example find this query into that exact text based searching, basically it means, so it says key I'm having a hard time signing in, so I will search the signing in related keyword, exact keyword matching into the document. But the problem here is, what if instead of signing in, we never mentioned the word signing in into our documents, instead we said logging. So see, you see the problem. As a software engineering point of view, it is a problematic, because if you do exact search based on the text itself, it will not give us the result, because it says ki I didn't find any signing in related keywords into the document. But the user is asking like maybe it say logging in, but we know as a like user and as a concept wise, it makes sense, signing in and logging in is the same thing, right? So doesn't matter user what is asking, that is why we want to use the LLM, that they are really good at it. So instead of storing the exact words, what we would do is we would create the embeddings of it. And what embeddings does is, it's like numerical representation of the actual text that we are creating the embedding from, and it is stored into the vector. Basically it represents the semantic meaning. And what are the embeddings? Well, it's up to you, now you go deeper, read about it. But basically it's just the numbers that into the vector we store it, and it represents. And there is this methods that we create these embeddings. So again, you don't have to write the code for it, also you will use already built-in models for that to create the embeddings. And but you need to understand what is happening behind the scene. So now instead it's not exact word, it's like a numbers there. So the benefit of the numbers is, so let's just say this is vector 1 embeddings. Basically in the vector form they store the embeddings, and vector 2. So basically it's like a some words we use from these documents, and this is the like vector that we created embedding basically, and this is the second vector that we created. Now that a query comes, this query will also go through this same method of creating the embedding. So we will create the embeddings of this query also, and let's just say key qv is the embeddings of that query that we come. So instead of now we don't search signing in or logging in, we search this query embeddings to the actual like these uh, sorry vectors. So now there are different methods. So basically it says ki the benefit of is this: there are two vectors, let's just say vector 1 and vector 2, right? Okay, now I want to see the distance between, let's just say I try to find the distance between these two vectors. If the distance is very less, like literally very less, then what it says about these vectors, it means ki the method that I use to create these vectors and the distance and I see the distance between these two vectors are very less, which means they represent similar kind of like a text. They must be generated from the similar kind of text. Are the exact same text used here and there? No, but the meaning is very close, because as I said, if you read about embeddings, how does they work behind the scenes, you would understand that those numeric are not just random mathematical number. They are created very using very sophisticated algorithms. So we can kind of trust these vectors. Ki, okay, these vectors have the distance very less, meaning they must represent some kind of relevant information into these vectors. So that is what we will use. So when we will search this query to the into these vectors, what we will do is give me the results, the distance between these vectors, or which is a threshold. We can define the threshold ki how less the distance should be between these two vectors. Give me those, and the how many documents we want. Let's just say we can say ki, give me the 3 documents or 3 vectors from that. So we will get the relevant information and the distance based on the distance we are checking. Now we don't care. So now the query, now either user might write ki sign in, login, it doesn't matter, because in the numeric representation, it represents a kind similar kind of information. So we will still get the relevant information. And if user says ki, something like ki purchase, so I know the purchase and signing out doesn't have to like correlation between them. So the vector that contains one vector contains signing in, and the one vector contains the purchase related document. The distance between these two vectors would be very far away from each other, and this is what we are doing it. And yeah, that's the idea behind them. And so let's go. Let me just remove it. Now, now you know the idea of embeddings and vectors. So what we do is we define. So instead, again, we don't want to create the embeddings of the entire documents at this point. The reason is, again, we don't want to like for example, let's just say I created the entire documents embedding and stored into the vector database. So what will happen when I try to query? Because it will fetch the entire document again, and I don't want the entire document. I want the chunks. So basically, there is something called chunking strategy that we use while storing these documents into the vector database. What we do is, okay, don't create the embeddings of the entire document. Instead, take 500 words. Again, chunking strategy is up to you. As a AI engineer, you decide the chunking strategy. So let's just say you say, okay, not 500 words is the like a decent thing for me in my application. So what you do is you start reading the file, take the 500 words, create the embeddings of it, and store it into the database. And you do the for the entire documents. That's it. So you store like 500 words chunks. So the benefit of, and you don't just store the like embedding itself. You what you store is let's just say you store something like those 500 words also you store. So for example, you can assume in an object way where this is the embeddings, and second you can use store the words that is this embedding was created from. Now the benefit of is that now you created this and you stored into the vector database. Now the query comes, you create the embeddings of QE is that query embeddings. Now you do the searching into the vector database and you get the 5 element. So the benefit of it that is those 5 will like the results will only contain 500 words, 500 words, 500 words, 500 words. So total like so those results will contain this 500 words, 500 words, and 500 words, and 500 words. So like for example, it's like a 2000 words maximum. Okay, and again, it depends on you. You might want 2-3 documents maximum, like 2 documents. So it's like 1000 words. But your documents had like millions of words, but you only found 1500 to 200 words. Oh, sorry, 2000 words. So that is like literally you reduced the context very less, and these are very close to what my query is asking in a embedding format or context meaning. Like for example, user might say I'm logging in or signing in. So either it is these documents that I retrieved from the vector databases. I know these are very close to this query. So I will just now I have this, and it's on server, by the way, it's on server, it's happening. Now I will generate a nice prompt. So basically what I will say in the prompt key, hey GPT or whatever the model that I'm using, hey, here is the prompt, sorry, here is the context that I'm attaching it to, and here is the query that whatever the query that user said, here is the query that I'm attaching it, and only answer from this context that I'm giving it to you. Don't do the global searching, and you just make a prompt very nice. It's up to you. This is what you do, and now you make the API call to this LLM, and now you can like be sure ki this LLM will do its magic. Again, as I said, it's very good at these kind of things. Okay, now you will get the result based on this relevant information, and now you can send it back to the user. That's a entire makes flow that you will be working on as a AI engineer. But this is just, what we did is just embeddings and retrieving and making the API call. All of these comes into this reg pipeline, retrieval augmentation generation. That's it. That's the entire thing. So the reg is not just one thing, it's like entire process of this: creating embeddings, creating chunkings, creating this app, making this API call, creating this prompting. All of these things comes under this reg pipeline. That's it. That's the literally most of the application that you see these days. Key document searching, internal support team, whatever that, this is what they use. Now of course there are so many things that could go wrong here. Like of course you need to understand about embedding, so you need to choose the right chunking strategy, hallucination. So for example, what if the this vector searching that we are getting, the retrieving from that database, is it valid or not? We there are so many like guardrails that we put, of course, but that's just an overview of it. Now this is just a reg. Now let's go one more further, which is agents. I'm sure you must have heard about these agents that is also coming into the AI engineering. So see, LLMs are good at text-based response, right? But what if you want to in this case we just return back to the user and that's it, the job is done. But what if you want to do some kind of action? So let me just remove this and let me just write agents. Agents. Okay, so what agents mean is it does something behalf on you. That's it. That's the agent's job, right? And we want to use the LLMs again. So the as we already discovered by now that LLMs are very good at context based question answer thing. They are really good at it. If you provide the enough context, they will give you a very good results. We made sure of that, right? Now we want to use that to do some things for us. So let's just assume, not just assume, but let's just say you want to build a PR like reviewer for your personal thing. So whenever some PR comes on this GitHub repo, you want to make sure that you don't want to just read the code and do the basic thing. You just want an agent is there which will do the either reject or accept based on some rules, and that is your goal to achieve. Now you want to use the LLMs for that. Now same thing happen. But like, I don't need to write it here. I can just explain it like this. So think about this way. In the GitHub, you can go ahead and use the GitHub webhook. So basically, any PR request comes there, the GitHub webhook will hit an URL, and the URL would be your server URL. Server endpoint. Basically, you can think about in this term, your server is running, and there's this endpoint which will get triggered based on the webhook whenever the PR comes to that particular repo, right? And in this endpoint, what you are doing is you have some functions basically that will get triggered, right? So in this case, what this function will do, you just say ki run agent something, run agent. This is just a function, normal function, nothing like extraordinary going on. This run agent, what will it will do? Now you know that this function was running from the webhook that GitHub on the GitHub you have like configured, and whenever the PR request comes, this agent will run. So basically, in this case, now what you will do is you will get the PR information, get PR information, get PR info. What? How will you do it? Simple. You will use the GitHub, to get the PR. Like you will provide your username, password, or whatever that relevant information for the repo and your credentials, and it will get the current PR info. Basically, what are the code changes happens, and who created it, and what is the difference or whatever the code, everything that related to code and particular PR, it will get that for you. Now you have that code. You can just assume this way. You have the code, and again you want to approve and reject. So obviously you would do some kind of guideline for you, right? So you might say, you know what, you have document which represent the guideline. So basically in this guideline there are mentioned key, okay, and this is how the naming of the function should be there, and there should not be SQL injection there, and there shouldn't be like more than this line of code changes happen. So you might check, if there are 300 more lines changed, then it means keep, no, don't just reject it, keep, don't write make it smaller, something, anything. You can just write anything here, and in this guideline you mention clearly. It's like a document. Okay, now you have the code, you have the like a guideline, and now again, as I said, now you, it's like the same thing that we did in the reg also, right? You make a LLM code which takes this code and this guideline, and basically you ask this LLM ki, okay, LLM, make sure, tell me, should I reject or approve this thing? If all of these rules are met, and the standard is same as this guideline, then suggest, accept, otherwise reject. Now again, as I said, LLMs are really good at it, so it will just either give you the accept or reject. And now based on that, you can just make a, either you can check if condition ki, or if the LLM suggests in the response, it's like okay, accept it, then you just do the accept PR function call. Basically, it's a function that will just accept your PR, and it's like a GitHub is providing you all of these things, by the way. Again, same thing, that the way you get the difference from this PR, right? And either reject the PR. This is also the function that you will implement, which will basically go to the GitHub and reject the PR. Or same for accept, it will go to the GitHub repo and accept the PR. That's it. That's what it is happening. And again, now we are doing the in this case, what we are doing is we are checking the if condition in the like response key. In the response, you can tell the LLM key, okay, either give me the reject keyword or accept keyword based on this. But instead of that, this is just a very simple like overview. But what we can do is we can provide the function calls definition to LLM also. Like instead of like, of course we know the LLM can't call the actual function, but what we can do is we can, instead of this taking this if and else, we can pass these functions to the LLM also. Like in the guideline, we can just say tools, something like tools. This is, and inside that this JSON type of information we can pass there, something like tool one, this array, where it says ki name of the function is accept, description of key of if the PR is accepted, call this function, something like you can might write it. And then arguments like token, whatever the credentials that you want, you can just pass this here. And same thing, second function, which is reject. So instead of saying ki give me the reject keyword or accept keyword, what we can in the in the prompt that we will generate, we will say ki okay, based on the like conclusion that you come, and we might say rating also ki if the score is around like 90%, you are sure ki the code is good and everything is met to the standard, then either call this tool basically. So this will return this tool, basically this function ki accept function ki, okay, call the accept function. In this, what it will pass the information related to that, like which API, which GitHub like PR we are calling, what are the credentials for that, what are the argument that we are passing, all of these things. And now on the server, it's our job is to call this function. That's it. Like call this tool basically. It will just take the name of that function, and we already defined it, so we will just call that and it will just pass it. So now we don't have to check these if conditions. We can just pass this exact schema to this LLM, and LLM will return this tool. We call this tool. That's it. In the response, and in the response we will extract that and we will call it. That's literally the agent, and it will run it. And this is just a simple, of course, a very simple overview of that agent thing. But there are multiple things that you can do. You can just book a flight, book a hotels, search something, whatever. There are so many things that you can do, but that's the entire idea. At the end of the day, what you are doing is you are calling the LLM for the decisions basically, because you want to make sure we have decided this, and this is have proven, like you have so many data for that. LLMs are really smart into this text based like context based question answer thing. They are really smart, so we want to utilize that capabilities. That's it. Other than that, other than all of these things are on the as AI engineer, it's our job is to make sure we pass the right context. Again, this is like a very first principle thinking basically. It's like, of course, you would, if you would pass like a right context and right information to the LLM, they will give you the right nice answer. That's it. So this is all we are doing here is we're trying to generate a nice context and we are passing to it. That's it. That's all we are trying to do. And of course, these are just a basic overview of it, so you might get some inspiration from it. Okay, now at least something makes sense to me. Now you might go deeper. You might want to go deeper from the very scratch of it. What are the vector databases, what are the embeddings, what are the chunkings, what is this retrieval, like this distance, how do we calculate it, what does it mean by calculating, how we are trusting it, What if this is hallucinating it because it's LLM? It doesn't understand the meaning that the way we humans do, right? It just numerically it's gives us the very accurate result, but it itself doesn't know what it means, right? So you know these things. Once you understand these things behind the scene, you know, okay, where do you as an engineer you can come. And of course, these automated things you would want to basically check, okay, whatever you're doing is like fine or not, whatever these are. So yeah, that's overall about AI engineering, and yeah, that's it. Happy learning.